Okay, time again for another video presentation. Last time we talked about static electricity, and this time we're going to talk about electric current. So we mentioned last time that it's the movement of electrons that really is the flow of electricity. And that's a pretty basic way of saying it, that electric current is the flow of electrons. It's not really true. What it is a chain reaction of electrons bumping into each other, but we can look at it as the flow of electrons. That's a convenient way of looking at it. Alright, so electric current, how much flow of electricity do we have? How much electrons are going on? Electric current is measured in amperes, so A is the unit for electron, amperes. Sometimes you hear it called amps, so you've probably heard this terminology before. Alright, and this amperes is about charges and how much charge goes by. So in a way you could look at it as like the flow of a river. How many charges go by per second in this case instead of water going by, it's charges going by. So 1 ampere is 1 coulomb per second. We talked about coulombs last time as being the unit of electric charge. So here is a device, the ammeter, that measures the current. And we'll be looking at some of these in class. And there you have it. So an ammeter is something that will measure the current. And we are now so evolved here with electricity that there are all kinds of appliances that are going to be used that run on electricity that'll give us all kinds of stuff. Yeah, from popcorns to toast to vacuum cleaners. Well, I think you're all very much aware of how electricity affects our lives. Don't you think about it as much, but there are electric signals that are going around in our brains too. So it's electric signals that really give us the impulses to think about the smells that we have or the sights that we see. So our brain is pretty wired up with electric signals as well. So yeah, electricity has something to do with us in a lot of different ways. Alright, so a circuit is going to be something that supplies a steady current, and the next video that we have will talk about circuits, but just getting the idea here that a circuit is something that will supply a current. And remember again that this flow of electrons can get some work done for you. There's a force involved, so there can be work done. And that's a pretty great discovery that people made. It's voltage that drives the current around the circuit. It's the negative being pushed away from the negative and drawn to a positive. And that's what the voltage is all about. So here you can see in a simple battery, you've got a negative side and a positive side. And once you've closed this circuit up so that the electrons can flow, right, then you're going to get a movement from the negative. The electrons will move away from the negative and toward the positive. So there's a circuit, and of course we can have work done by objects that are connected to that circuit. We're very wrapped up in that these days. Okay, so voltage can be measured with a voltmeter. So here's a voltmeter, something else that we'll take a look at in class. And there is a device that measures voltage, the voltmeter. Alright, so here's a little bit of a setup here, meant to be a little bit funny, but again, we're wired all around the house here, and we've got to keep track of what's going on. And what we have here is a circuit breaker. So this is a circuit box, and this is something that controls all the different circuits in a house. And there's somebody looking at their circuit box. Now if you have too much electricity flowing, you might have these circuits break on you, and when the circuits break, that will keep the electricity from flowing. If you overload your circuit, you can fry the wires in your house, and you'd rather have a little circuit break in there that'll keep that from happening. Okay, so here's the idea of the circuit breaker, and you may have seen some of this. Maybe it's in the basement of your house. I have one in my basement. This is the electric panel that controls all the different electric circuits that you have going on in your house. Okay, so yes, this is just again talking about the circuit breakers. And again, if the circuit breaker will trip if it senses that there's too much current going through, and that circuit breaker is set to break, you know, to turn off or open up the circuit so the electricity can't flow before, hopefully, your wires are destroyed, because that would be very costly. Circuit breakers have a sensor in them, but they used to use fuses more, and in your car you probably still have some fuses. And the idea of fuses is they're pieces of metal that'll melt, and these will melt if there's too much current, but they're metal that will melt before the wiring in your house will melt, or the wiring in your car will melt. And that's a way of protecting your circuits. This is what the fuses look like. I still have a fuse box in my house, so I have a combination of circuit breakers and fuses. In older houses, you'd have a fuse box probably. And this is what they look like up close, and the ones in your car are probably like this, but there's a small piece of metal in there, and once that melts, you replace your fuse, but that's better than replacing the entire wiring. Okay, so yeah, don't overload your circuits, I guess is what this picture is letting you know. Alright, so let's see. There is a resistance to the flow of electrons. The resistance in an electric circuit is, I guess you could relate it to friction, the idea that there's a resistance to this flow, and that depends on the material. And the resistance is measured in a unit called ohms. It's fun to say that, especially if you drag it out. Ohms, try it. It's very relaxing. This is the symbol for ohms over here, and we'll get used to that. Here's Ohm's law. Did I mention how much fun that is to say? Ohm's law, there it is. Well, current is measured in amperes, but it's represented by the letter I. So I here is for the current, and it should make some sense that the voltage is on the top of the equation, on top of the fraction over here. Because the bigger the voltage, the more the driving force for the current. And resistance ends up on the bottom of the fraction, because the greater the resistance, the greater the resistance, the less the current will be. So this is Ohm's law, and we'll apply this in a bunch of situations. Okay, so yeah, here again is telling you that the current, the symbol for current is I, the symbol for voltage is V, and the symbol for resistance is an R. And there's Ohm's law, very valuable law. We'll apply that in a bunch of different ways. Okay, so how about this one? Power is how fast we do work. We know that from earlier in the year. So power is work divided by time. So for electricity, electrical power is going to be current multiplied by voltage. Well, how about this? Current is the number of charges per second, and voltage is the amount of work per charge. So seconds will cancel out, and you'll be left with work over time. So electrical power, is currents multiplied by voltage. And there we go. Power is measured in watts. We've talked about that earlier in the year too. And in electricity, you probably even recognize the idea of a light bulb being measured in watts. We're very familiar with that. What you may not be familiar with is that they use the idea of watts to calculate how much they're going to charge you for your electric bill. And most of you probably aren't paying an electric bill right now, but that's something that you will get used to in the future. That's when maybe you're happy you're not used to that yet. At some point or another, you'll be paying for this electric. And really what you're paying for is energy, or you're paying for the amount of work that you're having done there. So if power is work divided by time, then power multiplied by time would be the amount of work. And if you remember, work and energy are related. The amount of work done is related to the amount of energy that you've used. And that's what they're really charging us for, is the amount of work that we have done or the amount of energy that we use. All right, so electrical energy is going to be power multiplied by time. And well, here's an electric bill. Good luck. That's some fun that's coming for you in your future, I know. But watts are kind of small to bill on. So what they do is they bill you in kilowatts. And for a unit of time, seconds, which we normally use in physics, is a little short. So they bill you for your kilowatt hours. So you're billed by the kilowatt hour. Pretty fascinating how human beings have figured that out and figured out how to charge for it as well. All right, here's the last topic on our short video for today, and that's a way of determining the resistance of a wire. And this is also one of the last equations that we have for the entire year for our AP formula sheet. So we've almost got them all figured out already. All right, so the resistance, do you remember what resistance is measured in? I'll give you a clue. It's ohms. But resistance is going to be equal to a resistivity. This is kind of like the coefficient of friction. It depends on the material that you're talking about, multiplied by the length of the wire. There's the L divided by the cross-sectional area. So typically we'll look at the wire as being a circle, and of course we can figure out the area of a circle, right? We could do that. So that is it for this video. We'll have some problems to try in class, and if you have any questions, bring them to class with you, and I'll look forward to seeing you there. Oh, as a parting glance here, here's where we're going. These are electric circuits, but we'll leave the discussion of figuring out what's going on with an electric circuit for the next video. Okay, thanks for watching.